Hey everybody, welcome to dotnetFlix. Hey Sander, how are you doing?
Hi Edwin.
What are we going to talk about today?
We are going to talk about Service Fabric Mesh.
Wow.
And we'll see how you can run serverless workloads on top of Service Fabric Mesh.
Okay, cool.
So, in this session I was planning to just do a quick introduction of Service Fabric in general, just like half a minute. Then have a look at Service Fabric Mesh, see what that brings to the table. And then we'll just dive into some demos. So we'll see how we can deploy an application to Service Fabric Mesh, how we can scale that application out, and then do some other fun stuff like mounting volume and doing some more network routing stuff.
Cool.
Sounds good?
Excited.
All right.
Let's dive in.
Let's dive in. So Service Fabric Mesh. I should probably preface this by saying this is all very preview.
Okay.
So right now Service Fabric Mesh is in a public preview, so you can try it yourself. But it hasn't GA'd yet, so I wouldn't use it in production workloads yet. I guess when this episode will air, it will probably be just before build.
Probably,
so
yeah.
Maybe there will be some new announcements at build, maybe some new previews, so we'll have something to look forward to.
Yes.
But just to take one small step back to Service Fabric in general, what is Service Fabric? Service Fabric is a lot of things. It's a pretty big platform, but fundamentally it's about building distributed applications composed of services, then getting those applications deployed to a Service Fabric cluster, whether that is on premises in your data center or up in the cloud, and then operate those distributed applications at basically any scale.
Okay, and if you talk about on-prem, is that Azure Stack? Or is it just a runtime that I can install?
It's just a runtime you can install your own machines, and there are no licensing costs involved, so Service Fabric is entirely free, so you only have to pay for your own hardware.
Nice.
Now before Service Fabric was available as an Azure Service, it was already heavily used inside Microsoft for many years. So a lot of services running on Azure, a lot of well-known services such as SQL, Event Hub, stuff like that, is all running on top of Azure Service Fabric. So as you can see, these are pretty mission-critical workloads. So you can say most of the important stuff in Azure runs on Service Fabric.
So it's pretty much battle-tested in production.
It's very battle-tested. Yeah.
Cool.
And there are a lot of different ways you can deploy a Service Fabric cluster. So, as I've said, you can deploy your own cluster on-prem, just take a couple of nodes and install the software on it. But you can also do that in another cloud provider's cloud. So, for example, you can use AWS at Amazon and install your own Service Fabric cluster there. And of course, there's an offering in Azure where you don't have to install the software yourself, but you can just click on some buttons and a cluster will be provisioned for you.
And is it just Windows or does it also do Linux?
It's Windows clusters or Linux clusters. Yeah, so basically you can run it anywhere. Now the Azure service is interesting because everything is set up for you, but you are still getting VMs and a VM skill set. And you still have some management to do with that. Yeah. It's still visible for you. With this new offering called Service Fabric Mesh, that is made entirely invisible to you. So basically, you can look at it as a big cluster managed by Microsoft, running behind the scenes. And all you have to do is take your workloads, create a little description about it, and deploy it onto that cluster. Now, as I've mentioned already, this is all very preview, so things may change in the future.
Will change, probably.
Will change, but it's still very interesting to look at Mesh to see where Microsoft is going with serverless workloads, and especially if you look at the application model they use in Service Fabric Mesh. So, with this offering, there are no VMs to manage, no infrastructure at all. Everything is deployed in a container. So nowadays we are very used to deploy stuff in containers. So that means basically any language, any framework, all your dependencies which are wrapped up in the container can be deployed. Again, you can use Windows and Linux. I believe the plan is to to allow applications to have a mix of Windows and Linux containers. There are also no Service Fabric frameworks. If you use the current Service Fabric offering, there is some tie-in to Service Fabric SDKs, so you've got dependencies there.
Application model that you have to use.
Yeah, exactly.
But that isn't necessary for Mesh.
That's totally decoupled here.
Okay, cool.
Yeah. And then you really are paying for only what you use. You've got per second billing, and you only pay for the resources you use while the application is being deployed.
Nice.
Now we have to talk about naming a little bit.
Yes.
Because naming is pretty hard in general. This product is called Service Fabric Mesh. When you think about it, it doesn't have that much to do with Service Fabric because I'm not seeing the cluster.
No.
The only thing I'm doing is describing my application in this application model and giving it to Azure.
It really is a platform that you run your application on top
Exactly.
of. Yeah.
Now if you look at the second part of the name, Mesh, as you well know, we've talked about this service mesh pattern 2 episodes ago.
Yep.
And it's also not really a service mesh. A service mesh is really all about abstracting the network, and this is much more than that. It's really an application platform.
Yeah.
So the naming is it's not a very happy name for the product, but it's what we've got.
Yeah, and it's really nice that this guy is talking about naming because he has 2 first names. Phil Carlton. So that's you can see that naming is very hard.
He grew up with it.
Yeah.
Yeah. Okay, so how do we actually deploy stuff into Service Fabric Mesh? Well, we basically create a template of what we would like to run in the cloud. And to create a template, we use these resources. So it's basically just an ARM template. And there is a new Service Fabric Mesh resource provider, in which we can use all these resources. So these are building blocks for describing our application, and I will go into detail in the demo.
Yeah. I don't know if you're going to talk about that later on, but I see kind of an analogy with, for instance, Kubernetes.
Yeah,
is there a relationship or?
Well, the way you use templates to describe workloads, it's a little bit similar. There's also a lot of YAML involved, naturally. I think Kubernetes on a slightly different abstraction level, because Kubernetes really is just a container orchestrator, whereas Service Fabric really tries to be an application platform that does more than just orchestrating containers.
Okay, makes sense.
Talking about YAML, so one way to create applications is to just use the Visual Studio tooling. And then if you create a solution, create a new project, you will get these YAML resource files. And for example, app.yaml, network.yaml, and that's where you describe what your application looks like, what kind of services you've got, what your network looks like, or what kind of ingress rules you've got. And the Visual Studio tooling takes all those YAML files and then basically transforms them into a ARM template, which is then deployed into the cloud. I'm not going to do this in this demo. I'm just directly going to create the ARM templates myself.
And I know that for Service Fabric you have a local emulator on your machine for development.
Yeah.
Is there also an emulator for Mesh, or is that not available?
Yeah, Mesh you can also run the emulator locally.
Okay, cool.
Yeah. So this new deployment model, which I've got, because in the the
current
in Service Fabric cluster, right? You've got these XML manifest files. Those are pretty verbose. This is a little bit more lightweight and a little bit smaller. You can also use this new resource model to deploy your applications to Service Fabric clusters. You may have already seen. So let's do some demos and see how this stuff actually works. So my demo is centered around an airport, and I've got a couple of services that I will deploy into a Service Fabric Mesh application. So a single application consists of a couple of services. I've got a check-in service, which travelers will use when they want to check in. That check-in service has to do some checks with the Homeland Security service, just do some background checks. I don't know what those guys normally do, but and then we've got some hardware in the airport. We've got sorters for the luggage,
Okay.
and we've got scanners for the luggage. And those hardware devices will call out to the sort servers and the scan servers. And then I've got this HTML5 client application to visualize all this stuff.
And that's for all the hardware to make sure that your suitcase gets on the plane.
Gets sorted to the right airplane, gets scanned if the just to check there's no funny stuff inside your luggage, right?
Yeah, makes sense.
All right, so let's dive in and let's deploy an application. So I'm going to switch over to my Visual Studio Code here. And you can see that I've got an ARM template open here. Mm-hmm. This ARM template just takes some parameters like a resource group, file share I'm using later on, a storage account key. It will use a secret, which is a resource type, to store the storage account. Yeah. And then we get to the interesting stuff. We've defined a Service Fabric Mesh network here. And this is basically the virtual network where my application and services will be deployed in. Yeah. So I've got an address prefix for that. And then I need some way to expose those services to the open internet so I can call them from my laptop.
And are all these services, can they communicate with each other over this network also? Or
yeah, so
do we have to do stuff for that?
So the services within the same application, within the same network, they can communicate to each other. Yeah. So the service names are automatically registered as DNS names. Okay. So to make those services available to the outside world, I'm creating a gateway resource. Mm-hmm. And that gateway resource basically maps from the open internet to my destination network that I've defined here.
And this will make sure that the for this, in this case on Azure, this will make sure that there's a network gateway and that there's an IP address and people can connect to it.
Exactly.
Cool.
And you've got to have some rules, some rules around ingress and some rules around routing. And here I've defined this, so I've got an open port 80. Whenever a request comes in, which ends in API passport, I will route that to my check-in service. And that's, that check-in service has a specific check-in service listener endpoint where I can route it to. And I'm doing the same for all the other services. So I've got my source servers and I've got my scan servers. Now you're not seeing the Homeland Security service here because that one doesn't expose an endpoint to the outside world. That uses queuing. So whenever the check-in services receives a request to check in somebody, it will add a queue, a message to a queue, and Homeland Security will.
So you can choose which services you will expose on the public internet and which one are just
private and shouldn't be exposed. Exactly. Okay. And good thing to notice here, I'm exposing all these backend services because my HTML5 client application is running locally on my laptop. And then I have to define my application itself. So I do this by creating a Service Fabric Mesh application resource. And the application resource simply contains a list of all my services. Yep. So I've got this check-in service, I'm running this on Linux, I've got Linux Docker containers.
Because this is .NET Core applications or?
This is a .NET Core application running in a Docker container, exactly. And this is the actual Docker container, so this is hosted up on Docker Hub. Yep. So Service Fabric Mesh runtime will automatically pull that from the registry. Then I've got some environment variables. I've got that endpoint we've talked about earlier. And then there's this interesting stuff about resources. So here I'm simply defining what kind of hardware this service needs to run. Okay. So I'm requesting a single CPU core and I'm requesting a gigabyte in memory. And this is basically the closest I will come to hardware. Okay. And then the number of replicas, so if I give in a higher number, it will be scaled out. Okay. And then I'm telling it to run inside my network. And that's basically it. I've got the other services here. And then finally, I've got some stuff around volume mounts, but I will get to that in my second demo. Okay. So, let's deploy this. So how can we deploy this ARM template? I'm using the Azure CLI for this.
Yep.
So I've installed the mesh extension so I can do AZ mesh. And then let's pull up the help so you can see that there are some, you can see all the resources here, and on each resource you can basically create a new one, delete it, show what's there, right?
I see an interesting thing. I see an app and a deployment. Is there?
Yeah.
What's
So
the difference?
so when I want to deploy something, I create a new deployment,
Okay.
which is basically an instantiation of my ARM template.
Okay.
I can use AZ deployments. So
Mesh.
yep. Always forget that one. Deployments, H. You can see I can create deployment, and then it will start deploying, and once the deployment is done, I can go to the app
Okay. Then
resource,
it's an application.
and then it's an instantiated application, and I can manage the application through that.
Nice.
Yeah. So let's create a new one. So I can use AZ mesh deployment create, and then I'm definitely going to copy paste some stuff because it's a little bit long. Let's see. Okay, so what am I doing here? I'm creating a new deployment and giving it my template file, which is in deployment Service Fabric Mesh JSON, which is the file I've just shown you.
And then the parameters.
And then I'm passing all the parameters. So the parameters consist of the location, file share name, and some other stuff. So I will just have this run for a little while. It usually doesn't take too long, maybe a couple of minutes at most, and my application will be deployed.
And you created something up front, so you already have a Service Fabric account or instance running in the cloud, or does it create it for you now?
Nope, I haven't. The only thing I've created is a resource group.
Okay, yeah.
And that's basically it.
Oh, nice.
Yeah. So there isn't a concept of a cluster anymore in Service
Exactly.
Fabric Mesh. So you don't have to create a cluster and then deploy something to a cluster. You just create this single template and deploy it to the cloud.
So you basically deploy a Service Fabric Mesh application to Azure in this case, and then it deploys all the stuff for you and starts running.
Yeah, and I will show you in the portal in a second when this is done running.
Okay.
Okay, so this deployment is done. So basically now we've got a application up and running. So we can check that by doing AZ mesh app list. And this will show all my applications running in Service Fabric Mesh. So we've got my AirportMesh demo running.
Cool.
But I don't have the IP address yet, so where do I connect to? Well, we can do that by using the gateway command. So again, list. We will get all the gateways, which is just a single one. And you can see that we've got an IP address, and this is where my ingress point is, right? So let's see if it's really deployed. So if I go over to a new Chrome window, I can go to that IP address, and then I'll just have to hit one of the services. So let's go to the sort service and give in some flight number, and it should respond. So there's the result. So my container has finished spinning up and everything's running, and we get back this amazing result of 0, which basically means that luggage from KL545 should be routed to conveyor belt number 0.
Okay.
Yeah?
Because you have inside information about the model, but
I have
will
inside
assume this is
business
correct.
logic
Yeah, of course,
information.
of course.
But the important thing here is my service is up and running.
Yeah,
Right?
cool.
So let's go.
And it's available publicly on the internet.
And it's
so
available publicly.
The gateway is up and running.
Yeah. So let's go over to the Azure portal. So I've got a AirportMesh resource group where I deploy the template. And we should see a mesh application here.
Nice.
So this is the application we've just deployed, and you can drill down even further here and see all the services. And let's just look into one, how far we can go. We've got a replica, so I've only got a single replica here. Let's go to that one. Then we've got a code package, and my code package is basically my container, right? You can see it here. The container image is a Molenkamp AirportMesh, blah blah blah.
Yeah.
So if we go even further in, we will see some logging about a container, and I can even, if I click on the logs tab, see the the console output, which isn't nicely formatted because I'm zoomed in for the video, but you can get the gist of this, right?
Nice.
Okay, so those backend services are now running in Service Fabric Mesh, right?
Yes.
So let's move over to the front-end part. So I'm going to switch over to Visual Studio Code, open a terminal, and I've cloned my Git repository here. By the way, this is all up in my GitHub repo, so we'll include a link in the show notes, so you can try this at home if you'd like. Let's start by actually running the client application by entering npm run start. That will basically do a webpack build and start my client application. And
this is just HTML5, nothing else.
Well, it uses Phaser, which is a framework for creating games, which is also very useful for creating demos.
Cool.
So let's see what that looks like. It should be listening on local 8080. Okay, so this is my airport, and you can see we've already got some customers here at the check-in desks.
8-bit graphics customers. Nice.
8-bit graphics Zelda-like customers. The airport is much bigger than this, of course, because the luggage is going through the airplanes through a sortertron, which right now isn't sorting anything. It's just sending everything to conveyor belt 0, which is the upper conveyor belt.
Yeah.
And then, of course, just to be secure, we also send the luggage through the scannertron, and that will scan each suitcase. When it finds something iffy, it will pushes it to the side, and otherwise it can go on to the airplanes.
Nice. Scannertron. So I'm assuming you played Thimbleweed Park?
I definitely played Thimbleweed Park.
Okay.
Now the goal for our airport is to get a lot of shiny happy travelers.
Yeah.
And as you can see in the top left corner, we are not doing so well.
Nope.
In fact, we are doing worse by the minute. And that's because they get a really lousy experience at our check-in desks, because this takes way too much time.
Yeah.
Now the reason for that is because we have to do all those Homeland Security checks. And as I've told you before, we've got a queue there, so work items are being queued, but there's just a single instance of the Homeland Security service doing all that work.
The replica count was 1, so you have
count
one
was
instance.
1, exactly.
Makes sense.
So we can speed up this process by adding some more workers.
Nice.
So let's scale out that service. So how do we do that? Let's go back to our ARM template. I've got an additional template here, Service Fabric Mesh scale out. And I've only made a single change to the template, and that is the replica count of the
Homeland Security.
Homeland Security service. Thank you.
Yeah.
So this is my service, and let's see, where is it? I'm now saying that I want a replica count of 3, so I want 3 instances of that service. So let's deploy that to the cloud. So again, I'm going to just copy and paste this command. You don't want to see me making all those typos. So let's wait a little while this runs. Okay, so this template is done deploying, so we should now have 3 workers. So let's switch over to our airport scene, and let's just see how those guys are doing now. So you can see that the service is improving, at least. So we've got 14% shiny happy customers, 22. And now what's up with this guy? I do know there are still some bugs in my front end, so let's just refresh it a little bit. Everything seems to be pretty well in order right now. Yep. If you go over to the portal, and we'll just have another look at the AirportMesh app, we go to the Homeland Security service. You should also see now that there will be 3 replicas.
Cool. Yep.
So number 0, number 1, number 2. Okay, so this is basically how you can scale and You can even apply some outscaling rules. So you don't have to do this manually. Based on CPU load or memory load, stuff like that, you can also auto-scale.
Cool.
So let's look at a different part of the template. Let's look at this bottom part here, which is all about volumes. So, as you know, if you want to store some state in a Docker container, it's not really best practice to store it in the container, because when the container restarts, you will have lost your state. So you need to store that state somewhere outside the container, and that's where volume mounts come in. Now, Service Fabric Mesh basically provides you with two different options. The first one is a replicated local disk, which is basically a disk on of the cluster, right? And it's kept in memory. So it's very high performant because the data is very close to your compute. It's also more expensive because you're using more resources. The other option is to simply use good old Azure file storage, which is cheap, but is slower because you are doing network hops going to Azure file storage. So what I'm doing here is I'm saying I've got this share, which I've already set up in a storage account, and then my service, the sort service, let's see, where is it? Yeah, it's this one. So this is the service which is called if the sorter tron needs to find out whether it needs to route a suitcase to conveyor belt 0 or 1. That will use that volume mount to get some configuration data. And that configuration data is pretty simple. It's basically just a dictionary which contains a mapping from airline codes to conveyor belts, right? So everything coming in for KL, for KLM is routed to 0, for one-way air is routed to 1. Okay, so the sort service tries to find that file, and right now it doesn't find it, and it routes everything to 0. So let's change that. Let's go to my storage account, which I've got set up in this other resource group, AirportMesh support. So I've got a storage account, AirportMesh, and in that storage account I've created a file share. So let's go to files and to the sortertron file share. And now let's upload the sort instructions. So I should be able to get this from projects.
And it will be aware that a new file is being uploaded and then reload this configuration, or do you have to do something for that?
That's dependent on how you write your application.
So you have
right now, whenever the sortertron, the sort source gets a request from the sortertron, it will check if that file exists. So let's upload this. And let's go back to our airport mesh scene. Now we've got a red and a blue suitcase coming. And you can see the red one, that's one-way air is sorted down, and the blue one is sorted to the right. Right?
Cool.
So that's really a very simple case of using external data and loading it in your Docker container using volumes.
And within the Docker container, it's just like opening a file on your local file system, but it's actually a volume mount from the container into the file.
Exactly. So if we have a look in the sort service, we've got a sort controller. I've got a method here, load sorting, load file, machine instructions. It just uses the system.io namespace. Cool. And it simply uses the read all text deserialize. Normal stuff, right?
Nice. Yep.
Okay. Now there's one other thing I have to mention here. Can you see those red LED lights on the Scannertron? Yep. That light should indicate whether a package is valid or not. And as you can see, it has some pretty weird behavior, because all those suitcases, they are okay, they are being forwarded to the airplane, but the light is still red. Okay. Now, I have some built-in functionality here, where I can add IFI packages to the line, and they are being diverted. And now the light's green, right? And another one comes through which is okay, and then that's red. So there's something weird going on because I want the behavior to be the other way around.
Yeah.
If a suitcase is okay, it should be green. If it's not, it should be red. Yeah. So let's have a look at the code and see if we can find a bug there.
It's probably Boolean logic error, as we all make
probably
on a daily basis.
Some Boolean somewhere. So let's go to the scan service and look at the scan controller. And the scan controller is pretty simple. It gets some X-ray data from the scanner. It runs that through a very sophisticated X-ray data analyzer, and it gets back a positive result if something iffy was found in the suitcase.
And it's pretty much some cool AI going on behind the scenes, right?
Probably. Let's look at it.
Oh,
yeah,
wow.
That's definitely some very sophisticated AI
learning.
algorithm going on here. Lost my track. So, as a result, it sends back Scanotron instructions. And those instructions consist of basically two properties. A Boolean for the light, which is pretty bad coding actually, because it's just a bool LED status, so you can understand why the mistake has been made. And it has a divert setting, which is just how hard to push the suitcase away, right? So these booleans probably are in the wrong order. So this should be false right here. This should be true.
Okay.
Now, luckily, I've already made a change. I've pushed it to a Docker hub with new version number, and I want to release this in production. But as we all know, things can go wrong when you push things in production. So I want to do a Canary release. I want to create a second service and just route some of the traffic to that service and keep the other conveyor belt working as it is.
Okay.
Then I can check it in production if everything is right. Then I can switch the other belt also off to the new behavior, right? So,
sounds like a plan.
How should we do that? Well, I've got yet another ARM template, which is basically just a copy of my previous template with some modifications.
And with another image file of Docker image.
Yeah. So actually, my let's see, where's my scan service? Is the sort service. Yeah, so my original scan service is still in here, right? Only I've now added a new one, which I've cleverly called vnext.
Yeah, because else it would take down the other one because it's not in the ARM template anymore.
Exactly, and we want to keep the other one running, right?
Yep, that's a top tip.
That's a pro tip, yeah. Don't remove your services from your ARM template if you want them to keep running.
Yep.
So this is targeting a new version of the image, a 1.1 image which has my fix in it.
Yep.
Now the only thing left to do is to make sure that some of the traffic is being routed. Now luckily in the request that I'm making to the Scanotron there's a header which indicates, it's a custom header, which indicates the number of the conveyor belt.
Okay.
So I can make a rule to just route everything for conveyor belt 1 to the new servers.
Yeah.
And those rules are set up in the gateway. So the gateway has all the existing rules, but now I'm basically creating a composite rule. I'm saying if the request matches API scan, but it also has a HTTP header of X process area number 1, then routes it to the vnext service.
Okay. Yeah.
If this rule doesn't match, it will just fall through to the next one, and that's the original rule.
Yeah.
So all the other stuff's being routed to scan service, right?
Nice.
Okay, so let's deploy this. So let's copy paste, bam, and let's wait for that one to be done. Okay, so this deployment is also done, right? So now we should have our fix in, and let's test it. Let's see what
both the
see what
V1
happens.
and the V1.1 are now in production.
Yeah, and you can see it already working. So we have to wait for a red suitcase, so you can see the suitcase okay, and this is turning to green. So, and as you can see, the other one at the top is still unaffected, right? Now we should also check if a IFI package still works, but so that should turn it into a red. Oh.
Okay.
Okay, so that's not particularly the type of behavior we wanted. it should just divert it a little bit, not throw it against the wall. So let's see what happens here. Let's go to my other branch and go to the scan controller. Okay, so I can see what happened here. So we fixed the boolean,
Yeah.
but we inadvertently changed the divert setting to Thor's hammer instead of just a little nudge.
Okay.
But this is exactly the kind of thing why I do Canary releases, right?
Yeah.
You want to make sure it really works, and then if stuff like this happens in real scenarios, stuff didn't work out, you only have impact on a small part of your system and not everywhere. So that's basically the entire demo I wanted to show you today. And that's basically all the stuff around Service Fabric Mesh I wanted to tell about today. So I think it's a very cool platform. I'm very excited to see where Microsoft is going to take this and application model in the future. So yeah.
Cool. And is there any indication on whether or not this will become GA and when that is, or is it just preview?
It's just preview right now. We will have to wait for build future now with announcements for more stuff like that. But it's fun to play with, and it's interesting to see where they are trying to take serverless computing.
Okay. And this is all up on GitHub, so we'll
this is all up on GitHub. You can
notes.
try this yourself, play with it.
Awesome.
Yeah.
Okay. Thanks so much.
Thank
you guys for watching, and maybe you will start playing around with Azure Service Fabric Mesh. Pretty cool stuff. And see you with the next episode of dotnetFlix. Later.
Bye bye.